Okay, so we're going to go over a couple of like review problems. And so this is from 4.5 ready. And we're really talking about sine, cosine, tangent of the angles. So a couple of things that I want you to remember from before is that sine, cosine, and tangent are just ratios of sides, meaning they equal to a side over a side of the triangle. And you just have to remember which sides we're talking about based on if I give you sine, cosine, or tangent. So a mnemonic that has been going on for like literally ever, probably not true forever, is so ka to a. And what SOHCAHTOA means is sine is opposite over hypotenuse. So before I get into all of this stuff, I need to define what opposite, hypotenuse, and adjacent are. Okay, so I'm going to be talking about sine of A because that's what they tell me to do first. They say sine, cosine, and tangent. So I'm going to be talking about A. Now, the hypotenuse of the right triangle is always the hypotenuse, regardless of which way you spin it, which angle we're talking about. This guy is always going to be called your hypotenuse. The hypotenuse of a right triangle is always going to be the guy opposite across from the right angle. He's the longest side of the triangle, right? So you should be thinking, oh yeah, the Pythagorean theorem. That's right. Okay. So yes, yes, ma'am, yes, sir. That's exactly what you should be thinking of. Okay. Now, according to so like angle A will have an opposite side and an adjacent side. So if you think about what these words mean, it will never be confusing. Like, don't memorize these words for words. Like, actually understand and think about, oh, that's what it means. So the word opposite means like across from. So now I want you to choose from A, if this is our angle A, and we're talking about either 9 centimeters, this guy, or 12 centimeters, this guy. Who's opposite of angle A? Who would be opposite of angle A? Yeah, it's 12. And the reason why is because it's facing it. So let's pretend that me and you were playing, I don't know, chess, or we're playing a game, and most likely we are sitting across from each other or opposite of each other. So that's what I think about these two. Like if you look, A is opposite of 12. Does that make sense? Across from 12. Okay, so this guy is considered opposite of angle A. Does that make sense? And it's important that I said opposite of angle A because look, do you think that this side, 12, is opposite of angle B? And you're like, no, not at all. These two are kind of like next to each other. Okay. Yeah. So this is called opposite of A. 12 is opposite of A. So then what would this guy be called? Well, this guy is next to A, or another word would be called adjacent to angle A. Oops. Adjacent to angle A. Okay. Now, and notice I put my reference points here of angle A, because that's important. I can't just be like, oh, that's opposite. Opposite of what? Does that make sense? Okay. And adjacent. Adjacent to what? What are you talking about? So here, what I'm going to do is I'm going to now find the sine of angle A. So notice when I take the sine of something, I'm giving you the angle and I'm saying find the sine of this angle. And then I say, okay, well, it's opposite over hypotenuse. So you want me to write the opposite side? Uh-huh. How long is that opposite side? And you're like, oh, it's 12. So then I'll put a 12 on this side. I'm just going to write it on this side. It's going to look like Yoda to you. You guys are going to be like, shouldn't it be over here? No, it's the same. If I say 4 equals to 2 plus 2 and 2 plus 2 equals to 4, it's the same thing, right? So that's the numerator. And then my denominator is the hypotenuse side. So which side is my hypotenuse side? Yeah, it's 15. So really you're done, or you can simplify, but really you're done. So I'm going to simplify to 4/5. Does that make sense? So let's go over this again. In order to solve these problems, you have to be comfortable with knowing who is opposite of what and who is adjacent to what and which one's always going to be your hypotenuse. Okay, so I'm going to pause really quick, but I want you to try doing cosine and tangent of A. Just of A. Just do cosine and tangent. Okay. Okay, so now that you've tried cosine of this angle. So the first thing that you're going to do is you're going to say, oh, cosine means, and then this means adjacent, and this is hypotenuse. So you're going to write adjacent over hypotenuse. And for the first couple ones, going to be honest, I write adjacent over hypotenuse until it gets itself inside my brain. Once it's done being in, like, I already know this, I don't write this anymore. So I'm using this to remind myself of that answer so I don't have to keep referencing it back and forth. Because during a quiz or a test, that's a lot of time to be looking up stuff, right? So I'm looking for A's adjacent and the hypotenuse. So what did you all get? What did you get for adjacent over hypotenuse? Perfect. So both of you said 9 over 15. And then you guys said, okay, well, I can also simplify it to 3 over 5. Good. And so the interesting part here is this, if you think about that number 9 over 15 or 3 over 5, you're like, hey, wait, Miss Johnson, this is weird because this angle has two equivalent answers and one of them doesn't have any, well, it does, but it's a smaller version of 9 and a smaller version of 15. And so one of the neat things that you'll know is because the angle is the angle, like it's however many degrees this is, it doesn't matter how big or small this triangle is, the cosine of that angle is always going to be the same. So perfect. And then we move over to tangent and you're like, oh, it's opposite over adjacent. And you're like, oh, that's 12 over 9. And we write that out and we're done. So those are yours. The reason why I said to separate B is now I'm going to erase adjacent to A, opposite of A. I'm going to erase all this stuff because now if you look at angle B, this is not the opposite of angle B, right? This is not the opposite of angle B. This is actually the adjacent of B. So you'll notice a couple of things. So the first thing I'm going to do is erase all this because I don't want anybody to get confused. And I'm going to ask you guys, okay, well, now what do you think the sine of B is? So this, I'm going to show you exactly how I would do this as a student. I would say, okay, sine is so that's opposite over hypotenuse. Okay, so I'm looking for B's opposite. So angle B's opposite is 9 over the hypotenuse, which is 15. Wait, I feel like I've said this answer before, which is just 3 over 5. And you're like, hey, Miss Johnson, look. Is that a coincidence that the cosine of angle A and the sine of B are the same answer? And if you think about that, it makes a lot of sense, right? Because, follow me, cosine is adjacent. A's adjacent is B's opposite. I'm going to say that again. Cosine involves adjacent. But A's adjacent is B's opposite. So it makes sense that these two would match. Hey, Ms. Johnson, do these match all the time? I don't know. That's for you to ask really good questions and for you to think about, I wonder. Okay, so then cosine of B, I'm going to write again. Cosine of B is equal to, let me see, it's adjacent over hypotenuse. And you want me to find the adjacent for B, so that's 12. So that's 12 over 15, which... Oh, 12 over 15 is the same as 4/5. Oh, Miss Johnson, look. The cosine of B is equal to the sine of A. Miss Johnson, it happened again. Right? Oh, I wonder if these two are going to be equal. Tangent and tangent. I wonder if those two are equal. And you already know because you already did this problem, sir. So again, tangent is opposite over adjacent. So tangent, B's opposite is 9. So it's 9 over 12. And you're like, oh, it's not the same. And you're like, wait a second. They're reciprocals of each other. Wait a second. That makes sense. Because this guy's opposite is this guy's adjacent, right? So every single one of these problems is going to be the exact same. If I put square roots in there, if I put square roots in the hypotenuse, it's all going to be the exact same work. I do kind of want to show you a little bit of this one because something interesting happens with some of the answers. And I want to make sure that you guys are comfortable with it because depending if you're going to be taking your SATs, you have to be comfortable with the square roots and where sometimes they're equivalent to. I guess I'll say it like that. So I'm going to work on A really quick. So can you do that really quick? Can you find me sine, cosine, and tangent of A? I'm not going to do the whole thing, but sine, cosine, and tangent of A. Okay, so we're going to work on sine of A. So sine, again, is opposite over hypotenuse, which is equal to what? Which is equal to what? So whose A's opposite? I keep saying this wrong. Whose angle A is opposite? Very good. It's 1. So our answer is 1 centimeter over 3 centimeters. Very good. If you actually put centimeters here, Ms. Johnson, should we put centimeters here? No, actually. Because if you remember from, let's see, where did you learn this? In integrated 1 and then in chemistry and a couple other places, you learned that units like centimeters themselves can cancel. So these two units would cancel, and I'm just left with a ratio of 1 part to 3 parts. So for every 1 part this way is 3 parts this way, right? Okay, let's do cosine. So cosine is going to be root 2 over 3. So this is root 2 over 3. And you're like, Ms. Johnson, you didn't write adjacent over hypotenuse. I know. So right now, your brain should be like, oh, yes, it's adjacent over hypotenuse. And you're maybe writing these definitions less and less. And then we get to tangent. And we say, okay, well, it's opposite over adjacent. So this is 1 over root 2. Okay, I'm going to do a lot of explaining here, but I want you to understand where I'm coming from. Okay, like this, I'm talking old school. Old school teachers will tell you, no, you cannot have a radical in the denominator. You can't have a radical in the denominator. You can't have a radical in the denominator. Now, look, you can have whatever you want wherever you want it. But if your teacher tells you can't have a radical in the denominator, then you got to go with what your teacher says because they're the one grading you. So I'll explain a couple of things. Me as a teacher, I'm okay with radicals in the denominator, and here's why. So the reason why your teachers will say, no, you can't have a radical in denominator is because whenever we're talking about division, right, you can only divide by whole numbers. So think about long division, right? So when you're doing long division, you're dividing by a decimal, what's the first thing that you do? You move that decimal over, right? And the reason is because back in the day when people used to divide, they used to divide by hand. And so dividing by like 4 makes sense. Like how many 4s go into this number? But dividing by root 2 doesn't make sense because this number literally goes on forever. So I can't move the decimal over enough places because I'll be doing that forever. But now with technology, the technology we have, it's okay to have radicals in the denominator because we have access to technology that'll allow us to do that. That being said, if your teacher says, you can't have radicals in the denominator, you got to follow suit. So I'm also going to say that in certain tests, say like ACT, SATs, and all those other high stakes tests, they're going to ask you for equivalent forms of things. So they're going to play off the idea that you understand how to get a radical out of the denominator. So that's what I'm going to focus on really quick over here. So if I wanted to get, actually over to the right, to the left, sorry. If I wanted to get a radical out of the denominator, this is what I need to do. So 1 over root 2. So I'm going to multiply it by the number 1. It's not going to look like a number 1 because it's not going to be like 5 over 5, right? I'm going to multiply it by something. And my hope is that when, after I multiply it, I don't have any radicals in the denominator. I don't have any radicals in the denominator. Okay. So you're like, okay, so what, Miss Johnson? Yeah. So what can I multiply root 2 by? And then all of a sudden I don't have a radical anymore. That's what I want you to think about. What can I multiply root 2 by? And then I don't have a radical in the denominator. So it can't be like 5, because that's not true. It'll just be 5 root 2. So, hey, Ms. Johnson, can I multiply by another radical? Sure. Radical what? So I will tell you, it's radical 2. So if I multiply root 2 times root 2, yeah. If I multiply root 2 times root 2, I get root 4. And what is root 4? What is the square root of 4? And you're like, oh, it's 2. And you're like, oh, that's exactly what we want to do. So how do you get rid of the radical in the bottom? By multiplying it by root 2. Now you can't just multiply something by root 2. That'd be really cool if I'd be like, hey, $20 bill, I multiplied you by 10. Yay. No, it doesn't work like that. So I can only multiply it by the number 1. So I'm going to put a root 2 on the top and a root 2 on the bottom, which is the number 1, right? So now I'm going to multiply 1 times root 2. Oh, that's root 2. Oops. That's root 2. Okay. And so this is equivalent to this. So one of the famous questions that you could be asked on a high stakes test is, which one of these is the answer? And it'll have several of these that are all equivalent. But now you're like, no, the answer has to be this one, right? But they say select all that apply, all that are true, all that are equivalent to this. And now you have to be comfortable with looking at this and being like, oh my gosh, they look so different, but they're the same. But you've been doing this since you've known about money. This is a $20 bill. This is 2 $10 bills. And they look really different, except for their value is exactly the same, right? So this is the one that I wanted you to think about in terms of this. So that's what I want you to practice. There'll be more videos on, this is called rationalizing the denominator. This is one way to rationalize the denominator. Okay.